Hello,
Hi, Shreyas.
can you see me?
Yes,
Okay,
yes, yes,
yeah,
I can see you.
okay.
Okay, am I visible to you clearly?
Yeah, I can see. Yeah, I can see.
And this whiteboard also?
Yeah, the Bible also.
Okay, great. So, I would like you to introduce first of all, please introduce yourself about your class, school, and about yourself, general.
Okay. So my name is Shreyas,
Right.
and this year I'm in 10 IGCSE. So I'm taking two sciences for 10 IGCSE. I'm taking physics and bio. So I've taken, um, and the third I have taken a humanity instead of chemistry. So I'll be giving my boards in May and June, in both of those months. So
Okay.
yeah.
Okay. So, Shreyas, I think you already know that myself, Neha Sharma, and here I'm here to teach you physics, and this
Okay.
is a demo class. And
Yeah.
before
Yeah.
starting the class, I would like to tell you that if in between, if you find anything difficult or you don't get any concept, you can stop
Okay.
me in between and you just can ask me the questions. Right.
Okay.
So we
Sure.
will start with
Okay.
very
Sure.
basic concepts, and the
Okay.
topic for today, that is force.
Yes.
Okay,
Yeah.
right. So before starting, I would like to know what you know about force. What is force according to you?
So force as in I meant under force all of the topics that come. So so what we have under force is the Newton's three laws. Then we have practical problems. So those problems like numericals, not theory, but the numerical problems I sometimes struggle with.
Okay,
So those are the ones that I need to improve on. Otherwise, the theory part is okay.
okay, fine. So today we will start with the same thing, and we will discuss numerical problems also. So the
Okay.
basic concept of force is what is force. So I hope that you better know that force is what is force.
Is it a push or pull?
It is a push or pull, or if we
Okay.
elaborate the same definition, how can you explain it furthermore?
Uh, it is a force that acts on a body.
Right. Force is a force.
Yeah,
Force
it
is a
is a
push or pull.
force.
Right.
I don't know what else to say
Right,
for
exact. Okay, no problem. Actually, force is a push or pull. Okay, you are right, but it is a
yeah,
very compact term to explain force. So basically, you can
yeah.
say that it is a push or pull, or we can say
Okay.
it is an external agency which we are applying on a
Okay.
body, and that is
Yeah.
basically bringing up so many changes in a body. And the
Okay.
changes
Okay.
could be many changes are there. Like if a body is at rest, we can bring it in a motion. If a body
Yeah.
is
Yeah.
moving already, we can change its speed or we can stop it. We can
Yeah. Yeah.
change the direction and many other things. We can change the shape.
Yes.
So
Yes.
it
Yeah.
is push or pull, and elaborative form is push or pull when applied on a body. It brings changes in a body,
Okay. Okay.
many
Okay.
changes. Okay.
Okay.
So apart from that, we have Newton's three law. But before starting that, I would like to know that what is weight, because it is in contrary with the force. So I would like to know what is weight and how can you explain?
Weight is the force of mass due to caused by acceleration due to gravity. So we
Exactly.
take mass into g, and that is g, the value of g. So
G,
to
and the value of
calculate weight,
value of G is
value of g is 10,
10,
10
or
meter per
more
second square.
precisely, it is 9.8 on the
Yeah,
surface of
yeah,
Earth
9 1.
when we are
Okay,
talking about
we have
something.
to. Yeah, we can use. I think we can use 9 also.
Right, you can.
Like the
No, no, no.
rounded off version they've
We,
told us.
we can't use 9, we can use 10 instead.
Yeah, 10,
9.8
9.8
or
to
10.
10. Yeah, nice. Sorry, 9.8 to 10.
Exactly. So, what we can say that a weight is also a kind of force.
Yeah.
You know,
Yes.
it is also
Yeah.
a kind of force.
Yes, of
Weight
course.
of
Yeah.
my weight is 50 kg. So,
Yeah.
if I am, sometimes people used to say my weight is 50 kg, but more precisely, it should be my weight is 50 newtons.
Yeah.
Isn't
Newtons. Yeah.
that? Because I hope you know that the formula for force is m into a.
Yeah. FMA. Yeah.
Right? Which
Okay.
law? Newton's which law?
Is it inertia?
Second law, first law, third law.
Is it second? I don't
Yes,
know.
exactly.
Is it
Yeah,
second? Oh
it is
yes.
second.
Okay.
Newton's second law. So we will call it as a Newton's law of momentum, because this term is this law is related to momentum. We come to that point also. But as we know, if force is m into a, and we are talking about weight, and you yourself were saying weight is equals to m into g.
Yes,
where m is mass here also and here also.
M is mass,
right?
Yes.
And this one is acceleration. And this one is acceleration due to gravity. But ultimately both are accelerations.
Both is acceleration.
Right. So if we are talking about unit of this term, it would be kg meter second inverse square. Am I right?
Yes.
But if we are talking about this term, so unit would be, again, for mass it is kg. And for acceleration due to gravity, ultimately it is acceleration.
Yes. So
that is another thing, that is the acceleration due to gravity. Otherwise it is acceleration only. The unit would be meter per second square. So if it is Newton, this term is called as Newton. Kg meter per second square. In a single word, we will call it as Newton.
Okay.
And this is again called as Newton. And in your syllabus also, if someone tell you to define 1 Newton, what is 1 Newton? How can you define it?
Then it will be the force exerted by unit mass due to acceleration due to gravity, which is kg meter per second.
Can you please repeat?
So it will be the force exerted due to unit mass due to acceleration due to gravity, which is 10 meter per second square.
Okay. Shreyas, what we usually do, whenever you have to define a unit, something 1 Newton, or 1 something, any unit, 1 dash, anything. So what you have to do is, Newton is a unit of force. Right?
It is,
And for mass, unit is kg. For acceleration, it is meter per second square. How can we define it? 1 Newton. This could be 1 only and only if this term is 1. And this term is also 1. Right? This is 1 and this is 1. So we can say that 1 Newton is the force. 1 Newton is the force exerted by a body of mass 1 kg.
Mass 1,
which is accelerated through 1 meter per second square.
Okay.
Understood?
So all units have to be 1.
Everything should be 1.
Okay.
Because 1 multiplied by 1 comes out to be 1. Right. So this one is the unit of kg, is the unit of mass, and meter per second square is the unit of acceleration. So now listen carefully what I am going to say. I am going to use all 3 terms, mass, acceleration and force, and substituting the value 1, 1, 1 everywhere. So the force is said to be 1 Newton. The force is said to be 1 Newton if the body of mass 1 kg is accelerated by 1 meter per second square. That is it. There is no need to cram any of the definition or anything. You can give your own wordings. Right. So that's the thing. We are talking about force and something. So now actually I was about to cover this later on, but still we started. Okay, now that is the concept of weight, and we can say that weight is also a kind of force with the unit Newton, right? Now what is the meaning of acceleration due to gravity? What do you understand by the term acceleration due to gravity?
It's force in an object that is in Earth's gravitational field.
Sorry?
It's the acceleration. So it's the force that the object experiences due to Earth's gravitational field.
Are you sure it is a force? You are saying it's a force.
It's a resultant because it's
Don't confuse. It is a quantity. It is a quantity.
Okay, it's a quantity, but it changes the motion of a certain object as well.
Right. Okay, leave acceleration due to gravity. You tell me what is acceleration.
Acceleration is change in velocity.
In velocity in a given time. Right.
Over time.
So over time. So if we are saying that if a person is moving with a velocity of 5,
Yeah.
and after 5 seconds the velocity is becoming 10, then 20, then 30 and 40, and keeps on
Yeah.
changing, then we can say that the body is accelerating, right?
Yeah. Yeah.
And
Yeah.
if similarly if the velocity is decreasing, again we can say the body is velocity is
It's
decreasing, then
decelerating. It's
deaccelerating
decelerating.
or
Yeah.
retardation, right?
Yeah. Yeah. Yeah.
Similarly, if a body is falling from some height,
Yeah.
for example Newton's gravitation law, if an
Okay.
apple is falling from the tree and
Yeah.
the body is falling freely, we are not
Okay.
throwing anything, the body is only falling under the effect of gravity. So
Okay.
acceleration due to gravity means what? If the body is at certain height and it is
Yeah.
falling down,
Okay.
the
Yeah.
velocity of a body keeps on changing.
Yeah.
Do you
Yeah.
know that? You have to keep that thing in your mind. So actually
Okay.
what happens if we are throwing, we are leaving anything is falling freely, the speed, the velocity of a body keeps on changing. So that means that body is accelerating.
Okay. Yeah.
And the second thing is the body is accelerating under the effect of gravity.
Gravity. Yeah.
It is moving downward by itself because of gravity. So that's why we will call it as change in velocity means acceleration, but due to gravity.
Gravity.
So that is acceleration due to gravity. Acceleration due to gravity on the surface of Earth is 9.8, and on the surface of Moon it is,
I don't know what it is on the surface.
okay, it is if a person weighing 60 kg on the surface of Earth, that person weighs 10 kg on the surface of Moon, because the acceleration due to gravity, that is G, is 1/6 of the acceleration due to gravity on Earth.
Okay, so it's 1/6 of 10.
1/6.
9.8.
Right. Acceleration. I'm writing it like this: acceleration due to gravity on Moon
Okay.
is equals to 1/6 of acceleration due to gravity on Earth.
On Earth. Okay.
Means 9.8 divided by 6.
Yeah. Yeah.
Okay. So that is the main thing, and in this way you can understand this, what is acceleration due to gravity and what other things. Okay, I am going to share a screen. I'm going to share my screen with you. Tell me whether it is visible to you or not.
Okay, sure.
Yes, is it visible to you?
I can't. Yeah, I can see.
Okay, so it is very much clear in front of you that it is depicting the concept of weight, which is equals to m into g, that we have already discussed. Okay.
Yeah.
And acceleration due to gravity also we have discussed. So I would like to discuss one more thing. I hope you better know it already. That is Hooke's law.
Yeah, Hooke's. Yeah, I forgot to mention Hooke's law. Yeah.
Yeah. What is Hooke's law?
Hooke's law states that extension is directly proportional to the load attached to it.
Exactly. And do you know? I don't know because I haven't checked clearly in your textbook. I don't know. Can you see? I don't know about your book. Here in front of you on the screen, it is given that F is equals to minus kx. Minus sign is indicated there in your book or not?
No, it's just k. It's just kx. So spring constant is just k. It's positive.
So actually, in actual, negative sign is always there in Hooke's law. So I will discuss why this sign is coming. Okay. So Hooke's law basically means, as you can see in front of you, spring is there on the very left side, and some load is connected to it, right?
Yeah.
So if we are increasing the load, definitely there is weight attached to the system. That load is basically a weight, some weight. So that weight is represented by F, because we have already discussed weight is a kind of force. What I'm saying is, if this is a spring and here I'm connecting some weight, a body, you can maximize my screen because I'm writing on whiteboard. You can maximize it.
I don't know how to do that.
Can you see a small dialog box on very right side?
Oh yeah, I did it. Yeah.
Just double
Yeah.
click it.
Top right. Yeah. Okay. Got it.
Okay.
Okay. I can see.
Right. So I am connecting a body
Okay.
with the spring, and mass of the body is m.
Okay.
So on connecting the mass, the spring is getting stretched by the distance x.
Yeah.
Okay. Because
Yeah.
of this mass, the weight coming into existence and the weight of body will becomes m into g. Am I correct?
Yeah. Yeah.
Okay. So now what is happening? According to Hooke's law, it states that the force applied on a body, and that force is basically a restoring force. Now what is restoring force? When I have a spring in my hand, I'm stretching it.
Yeah.
If I'm stretching it, after some time when I release it, it again retain the same shape and size.
Yeah.
Right? So definitely there must be some sort of force acting on it that is helping it to regain the same state.
Yeah. Yeah.
And we will call it as a restoring force. Okay.
Okay.
So this formula is for the restoring force. F is equals to minus kx. Now basically from where this formula is coming, according to Hooke's law, the restoring force or weight is directly proportional to extension. Okay. Yes, Shreyas, can you see?
Yeah. Exactly.
What I'm saying is, don't look at this side.
Yeah.
What I'm saying is,
I can see. Yeah.
yes. What I'm saying is, in this diagram, the weight is mg, and we have already discussed that this weight is a kind of force. So according to Hooke's law,
Okay.
the load is directly proportional to the extension. Load is proportional to extension. Here load is represented by F. Right?
Okay.
F.
Okay.
And extension is represented by this distance x.
Yeah. Yeah.
If I am applying more and more weight to the system, like initially 10 kg, then extension is 2 meters. If I am applying the weight of 20 kg, definitely the extension will increase.
Yeah.
Right? So direct proportionality means what? If this is increasing, this also
extension
increases.
will also increase. Yeah.
And I hope you know inversely proportional means if one thing increases, another one decreases.
Yeah. I know.
Right?
Yeah.
So what is happening here? If I will remove this sign of proportionality, a constant of proportionality comes into play or existence.
Yeah.
So that will be equals to F is equals to minus kx. Now why I am writing, if in your book if there is no minus sign, you can you avoid this, but I would like to introduce why a minus sign is here.
Okay.
Minus sign whenever comes in between, that also indicates if one thing is increasing, another one is decreasing or moving in an opposite way. Now I have told you that the spring, I'm stretching the spring.
Yeah.
Please pay attention. If you will not be able to understand, then tell me. Here, the force applied is in this direction.
Yeah, by the weight.
Initially. But if I will remove this weight,
the
restoring force will act in
upward direction.
Exactly. Right? And I have told you that this force is the restoring force. This force is the restoring force.
Yeah.
Okay. So the restoring force is this.
Yeah.
Okay.
Yeah.
Now we have two components here. This is a constant. This one is a constant. Two variables are there. One is force. Second one is displacement. Okay. Force is acting upward. Restoring force is acting upward. But when the restoring force is moving upward, at that same time, because the spring starts contracting, When the weight, I remove the weight, the springs start contracting.
Yeah.
So the extension starts decreasing.
Yeah.
So restoring force moves upward, and the extension, and the more the restoring force is increasing, extension is decreasing.
Yeah.
In upward direction, more the restoring force is increasing, extension starts decreasing. So when things are happening like this, one is increasing, another one is decreasing, that time negative sign comes into play.
Okay.
So whenever there is such case any such case arises, that time you would have to mention negative sign indicates that the force F and extension X are in opposite direction.
Okay.
That is the basic meaning of this Hooke's law. So we have a numerical.
Okay.
And I would like you to understand it, and we will solve it. I'll help you in solving this. So this is a numerical in front of you.
It's on. Okay.
Okay.
Yeah.
So try to understand first, and then let me know if you need any help.
I'll try and solve it first.
No, we will discuss it first, and then I'll give you some hints.
Okay.
A spring is stretched 10 mm by the weight of 2 newtons. Okay. So weight is given to you, the stretching, the value of x is given to you, the extension is given to you. Whenever you have to solve the numerical, by the way, here already mm is converted into meters, but if it is not, you just have to convert it into SI unit first and then try to solve it, right?
Yeah. Okay.
So it is already converted into SI. So this is the first part of the numerical. Okay. Now they are saying calculate part A, the force constant K. You have to calculate force constant. Force constant means K. So it is very easy. You have to use the formula of Hooke's law. Don't use negative sign. Just directly F is equals to Kx. You have the value of X. You have the value of F.
Yeah.
So you'll be able to calculate X from there. Secondly, they are saying if the weight W of an object, you have to calculate the weight of that object. If the extension will become 80 mm in same case, in same numerical. How will you do that?
Okay. So I can use the constant in the second part also.
Exactly, because constant will remains constant because we are using the same object. So we already have calculated the value of K. You just have to put it in the second part and then solve it. So can you please solve it?
Okay, sure.
Right.
Okay, I have one question.
Right.
So
yes.
does the constant have a unit?
No.
Okay, it doesn't have a unit. Okay.
No. Constant never have any unit.
Okay, got it. Okay, I'm done with the.
Okay. Both the parts?
Yeah, both the parts.
Okay, first one. Answer of the first part is?
So K is 200 for the first
one. Right. I have solved it also. Okay, second one?
The second part is 60 newtons.
Okay. So Shreyas, I would like to tell you that answer of your question, that whether it do have any unit. Yes, it do have a unit, because not always every constant is unitless, because if you will see this, we have Newton, If there is no unit, both the terms in numerator and denominator should be of a same type. As it is not, definitely it do have unit, that is Newton per meter.
Okay,
Right?
okay.
Because
Okay,
I hope I will relate it with something. Have you done with the concept that force, gravitational force?
yeah, gravitational force.
Do you know its formula?
No, I don't know the formula for
Okay,
gravitational force.
but
Only
just
force.
I would like to just relate it. Over
Okay,
there at that point also we have constants, but those constant do have units. So it's not mandatory that constant do not have unit. In this case, constant do have unit. That is Newton per meter.
okay, 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 got
Okay.
it.